Hi, I'm Rich Turner.
I'm Russ Alexander.
And we're here to introduce you to a very exciting new feature coming soon to Windows 10. At the beginning of the Windows 10 cycle, we opened up a user voice page and asked the Windows community what you thought of the Windows command line, what asks you may have of us, what features would you like to see added, what changes you might like to see come to the Windows command line. And we were inundated with your feedback. From the team, a very sincere thank you for all of that feedback. It has really helped guide us and helped us make the right decisions when it comes to planning for Windows 10 and for future releases. Out of that feedback, we got a couple of very clear themes that you asked for. One of which was to make some dramatic improvements to the Windows command line. The other of which was to add Linux tools and Unix tools to Windows. We began already in Windows 10 adding a few of the features that you already asked for to the console. We continue that work and we have a lot of news coming up on that subject over the next few months. But for now, for this talk, we'd like to focus a little bit on the second point here, which is adding Unix tools to Windows. So one of the key questions is, why would we integrate Linux and Unix command line tools into Windows? Well, it turns out that modern-day developers, especially those working in open source projects, today have to build applications and technologies that span the gamut, that span Windows and iOS and Android, and a lot of us who work on back-end and server infrastructure work with Perl and Python and Ruby, and an awful lot of open source technologies in particular that are native to Linux and Unix, and don't always work as smoothly on Windows as you might want. Now, a lot of those technologies are doing a great deal of work to make their Windows experience better, but we also wanted to add features to Windows to make Windows developers far more productive and to be able to use these tools much more seamlessly. So we decided to take a look at what it would take for us to bring Unix and Linux tools to run in and on Windows. We looked at a bunch of options and we weighed up the pros and cons of many of them. But ultimately, we wanted to create a technology story, a solution that was a long-term solution that was going to be solid and reliable, and the developers were going to be able to rely upon long-term. So, what was the solution? Well, we went completely crazy, and we decided to integrate Linux user mode and Windows. Yes, really. We've actually taken the Linux user mode code from Ubuntu, and we built a subsystem into Windows, into the Windows kernel, to expose an interface that looks, to all intents and purposes, like Linux, to a Linux user mode. So we've integrated Windows and the Linux user mode code to run smoothly on Windows. We're calling this Windows Subsystem for Linux, and we've been partnering with Canonical to bring you a version of Ubuntu. In fact, Canonical actually create this image of Ubuntu without a kernel, and we've taken their package and we've run it on top of Windows Subsystem for Linux. So, rather than talking about this, Russ, why don't we go and dig into this in a bit more detail?
Let's do that. So, what you're about to see for the demo is what you're about to see. It's all in preview mode. Some stuff works, some stuff does not work. We're obviously going to be focusing on the stuff that does work right now. But this is Ubuntu user mode running on the NT kernel. There's no smoke and mirrors here. We'll prove that inside the demo. We'll make that abundantly clear.
So this is going to start up a VM or something to run on top of Windows?
This is not a VM.
No VMs
no
inside?
No VMs inside.
No VMs.
So, nothing says what's going on like code. So let's actually show what's going on. Here we have the command prompt. We all know it. We all love it. We type in bash. You can see that we're now sitting at a Unix command prompt. Now, LSB release just shows you what it is that we're running. We are running the trusty version of Ubuntu at this particular point in time. Once again, we grabbed this directly from Canonical. There's no changes made to their image. This is something that an end user can go download off their site today.
So real Linux user mode already running on top of Windows.
Real Linux user mode running on top of Windows. Now, everybody knows that you can do an ls. That's not terribly exciting. Everybody always asks us to do an ls in the proc directory, so we'll start with that. Just to have some fun, we will cat whack proc, whack CPU info.
Wow.
Right. Genuine intel, all sorts of goodness going on there. Now, I'm going to be clearing the screen every once in a while so people can hopefully see it a little bit better.
Absolutely.
Now, as we go through, let's actually prove that we're running an elf binary at this particular point in time.
So ELF binaries are the binaries created by Linux's compiler toolset. It's the native executable format, essentially.
Yeah, instead of
Linux world.
Win32, it's an ELF binary.
Right.
So let's just pick something. We'll pick uname out of the bin directory.
Cool.
And you can see that what we're doing here is we're actually running ELF64, and it thinks that it's on Unix.
Real Unix code.
Real Unix code. Now, some of the stuff that everybody always asks about this one. Mount C. First off, can I see my C drive?
Wait. So you're going to show us the Windows file system from within Linux running on Windows?
Yes. Yes. So,
Wow.
Mount C dev. So I'm going into my dev directory.
Okay.
And you can see ls. There's everything.
Okay.
Right? So life there is good. Let's go into samples. Tab completion does work.
Nice.
See, and here I just have hello.c.
Okay.
Everybody knows hello world. This is something that everybody always starts with. Let's take a look at it in VI.
Wow, so there's Vi running on Linux, on Windows.
Yes.
I like this.
It's nice.
Let's do more of this.
So, we'll just quit out of this. We don't need to make any changes. It looks fine. And GCC hello.c-o hello.
So this is the GNU C compiler, compiling C code in Linux on Windows.
Exactly. So let's run it real quick. We just compiled hello world. Hello, once again, tab completion. Hello world.
And Hello World runs.
And then just to prove,
Yeah, prove that this isn't a Win32 app under the hood.
read elf hello. Once again, we just compiled elf64,
Right.
Unix, all sorts of goodness going on there. So, hello world is fun. Let's go into something a little bit more real world.
Bit more meaty.
Bit more meaty. I'm just going to go into my demo directory. Now, for everybody who's looking at it, I have a few scripts that just kind of make my life a little bit easier. There's no spoken mirrors on this. That actually, if you're watching the video, it'll actually pop up and show you what commands I'm running, so no big deal there. So, let's assume that I am a web developer. And as a web developer, I have this page. So, it says hello world. Not terribly exciting,
Not the most beautiful page in the world, but functional.
but functional. So it's running in Azure.
Okay.
You can see that this, yep, there it is, azure.com. And
And this is on ASP.NET, of course.
No, actually, this is running in Ruby. So
On Ruby.
this is running
Right.
on Ubuntu's Azure image.
Right.
Just up in the cloud. It's doing Ruby. It is a Sinatra app, and I deployed it using Mina.
Right.
So Ruby people know that these are two gems that you can install through Ruby, one Sinatra, one Mina. Now, I, as a developer, and all my code is sitting here inside of GitHub.
Beautiful, as it should be.
As it should be. So, I want to make this page a little bit more interesting. Now, one of the things that I can do is git clone. So I'm just going to go out. Oh, I forgot to install Git.
Ah, great.
So,
So in Windows, I would normally now go to find the Git web page and download the application and wait for it to install.
normally you would. That's not what you do in the Linux world.
If
though.
I was on Ubuntu, I'd apt-get. Oh, we're going to apt-get this in?
We're going to apt-get install Git.
Nice.
So you can see that this is actually going out, and we are grabbing apt-get from the same location that you would go out and get it if you were running it on Linux.
Very cool.
Take just a moment in order to unpack this. Sometimes it takes a little bit longer. This is kind of a work in progress.
But again, this is now apt-get running on Ubuntu, running on Windows.
Yes, Linux
I have to
apt-get.
keep saying this because this is a new day.
This is a new day. So, as you can see, I just installed Git from the same location that I'd be installing Git in an Ubuntu site.
Okay.
So now, let's run that same git clone command that I ran before again. And it goes out. You can see that I'm actually doing this via SSH.
Beautiful.
All the certificates and everything else works.
So again, this is Git running, that's been installed using apt-get
yes.
on Linux on Windows.
Yes.
I like it. Keep going.
That's exactly right.
Give me more.
So, now, if we do an ls-l, you can see that the Sinatra demo directory is new. If we pop over this guy, we go under demo.
You can see it in Windows as well.
You can now see that it's
Look
here.
at that. Beautiful.
So this is everything that I just grabbed. All right, so let's go into the Sinatra demo. We take a look. There it is. Now, for those of you that don't know, my code that says hello world is running in app.rb.
Cool.
All right, we'll clear this. Now, if I were in the Linux world, I'd run vi app.rb.
Cool.
This is the world's dumbest Ruby app, so pay no attention to that. But I am not. I am actually running on Windows.
You are.
So what do you say we come out here and we go to this app.rb and we modify it using Visual Studio Code.
Wait. So, you are now going to use Visual Studio Code in Windows to modify Ruby code that you are later going to compile in Linux on the same Windows box.
Pretty much, yeah. Not so much compiled, but yeah, basically.
I think we might need to draw pictures for some of this.
Some of it we might. So let's go out. This is where it said hello world. Let's say rar, because I like it saying rar. I just actually,
RAR is necessary.
And let's give it an image, because images are more fun. And we save, just like you normally would.
Cool.
I'm just going to shut this down. Now, for those of you running Ruby, one of the commands that you can do in order to test your app, because everybody should be testing their app before they actually run it.
Everybody should be testing. Test your code.
Test your code, is rack up. So this is now running Webrick. Webrick
Right.
is a web server on Linux.
So you're running your website in Webrick on Linux on Windows.
Yeah, just locally to
I'm
test.
starting to detect a pattern here.
There is a pattern.
There is a pattern.
It's a wonderful thing. You will note that we're hitting port 9292.
Yep.
So over here, I happen to have it up right here, localhost 9292.
Now wait a minute. If I was running this on a VM, Linux in a VM on the same machine, that Linux VM would normally get its own IP address, and what you're showing us is Linux running on the same localhost address as Windows.
Exactly.
Because they're going down through the same network stack.
Since it's running on the same kernel, it's hitting the same network stack. This is running locally.
Beautiful.
And you can see that my page is now up.
You should be a graphic designer, sir.
This is the extent of my skills. This is the absolute extent of my
Nice.
skills. So that's all well and good. And you can see that we actually hit it. Once again, no smoke
Oh,
and mirrors on this one.
Nice.
All right, so we just proved that this is working.
Yep.
Now, let's check the server. One of the things that we should do for the server is let's make sure that the server's actually up. Which should be a really good thing to do. So let's SSH.
So you're using Linux's own SSH
Linux's own SSH.
to SSH into a Linux server running in
Azure.
Yes? Right.
Yeah. So this is running SSH. I had all my certificates set up so it didn't prompt for username and password. We are now SSH'd in. Var dub. Let's take a look. As you can tell, I really like the alias LL.
Yes, you do.
So, Sinatra app. It's
Yep.
up and going.
Cool.
Life there is good. So let's exit out of here. Let's go back into my Sinatra demo. All right, so now
So you're going to now want to push that Sinatra demo up into the server.
I am. So git commit -a-m rar.
Cool.
So git diff. Oh, there is no diff because I just did
Yep.
that. Git push.
Cool.
There we go. Just
so
pushed
Git
it
has
up.
now been updated.
Git has now been updated. So let's push this out. Like I said, I have been running this, or we're normally deploying this via Mina. So Mina deploy. Give it just a moment. The red that you see are actually not errors.
And so that's pushed, Mina's now pushed your local copy of that code up into the server.
So Mina just used SSH to push a
Use
script.
Linux's SSH.
Linux's SSH to push a script to the server that then the server turned around and pulled the changes from GitHub.
Right.
So head over to demo. This was demo. We hit refresh and
A beautiful thing
There it
happens.
is.
Look at that. Fantastic.
so I just went through the day in the life of a developer in a very, very, very simplified fashion.
Sure.
To show what's going on and to show that you can actually like work with
Awesome.
Ruby on this. We did, yeah.
We actually have Linux, tools, Ruby, Mina, Git, we've seen Vi, all running on top of Windows.
We have.
And with nary a VM in sight, apart from the one running up in Azure, but that's a
Yes.
slightly
Yeah, we
different
don't.
story.
Yeah, that's so.
Fantastic.
Yeah. So how are we doing this magic? What did you just see? Native Git user mode once again coming directly from Canonical. It's the Ubuntu user mode untouched, and Windows subsystem for Linux. Essentially, what we're doing is we are taking all these syscalls and we're redirecting them in a way that's the Linux or that the Windows kernel can understand.
Right. So these are in Linux world, the syscalls are essentially the very bottommost layer of technology in the base of the user mode, essentially, that then calls into the NT kernel and does the work of the syscalls, like open, read, close, fork.
Exactly.
We have fork as well?
For this particular, if you're inside the subsystem, we have fork.
That's very cool. We should do a session on that alone.
We should do a session on
Awesome.
that. So, what works and what doesn't?
Yeah, now you said this was real.
This
How
is-
real is this?
Everything that you just saw is running code.
Cool.
Everything that you just saw is real. There are gaps. There are syscalls that we have not done. There are things that we know do not work.
Cool.
So the things that we've been testing a lot on we've been testing a lot on the core utils in Bash. We've been testing a lot with apt-get. We've been testing a lot with Ruby. We do know that a lot of the Ruby gems right now aren't working. We are working on that. We are trying to make sure that everything goes. Python, Git, all that good stuff. Things that we know don't work. Some examples. One is the top command. Top kind of messes up the terminal. It doesn't look very pretty right now.
Right.
We're working on it. I don't know if it'll be fixed by the time that people actually get to play with this. MySQL, so whenever you have a service that's running in the background, we often have things that kind of mess up, especially if you close all your Bash sessions, we close the services, stuff like that.
But as you said, this is a preview. This is just the first public release of this thing. But the team is working hard on this, I believe.
The team is working very hard on this. And yeah, we are trying to close as many gaps as we can.
Fantastic. Work in progress.
Yeah, work in progress.
And importantly, we need your help. We can only do so much testing, we can only get so much coverage, we can only play with so many toys and tools. We need your help to really kick the tires on this thing. We need your help to give us feedback, to let us know what does work, let us know what doesn't work, let us know what you'd like changed, what you think could be improved, etc., etc. Importantly as well, please do let us know what does work, because we don't have a comprehensive catalog of everything everything in the world of Unix and Linux that does work. We'd love to hear from you and find out what is working for you, as well as what isn't working. And please share your experiences. Feel free to blog, to tweet, to take this to user shows, to take this to user groups and to talk about it and to demonstrate it. Reach out to us. We're more than happy to help you if we possibly can with any of those activities. We are also going to be coming up with a bunch of community-oriented activities to help support you throughout all of this as well, and to communicate and share with you as well. We'll be creating a new user voice to allow you to provide direct feedback specifically around the Linux user tools. We will also be maintaining the command line and console tools user voice as well to drive features in that direction. We'll be supporting Stack Overflow, we'll be supporting server fault, and we will also be creating Twitter accounts and various other mechanisms for you to provide us feedback. In the short term, I would encourage you to please follow me on Twitter for now. I'll be publishing a lot of news and a lot of updates and a lot of announcements of things coming up, and also pointing you at lots of resources for you to be able to use and to get your feedback to us, so that hopefully we can build a product that you're going to be absolutely dying to use and making you very, very productive, to help you build applications on Windows that target everything, everywhere.
That's the plan.
With that, thanks for your time. Thanks for your help.
Thank you for showing it off.
Awesome. We'll look forward to showing you more soon.